All right, so let's look at maybe the other parts. So if I'm looking at, say, for example, the front wheel, as we saw, though there is a small amount of lift, there is definitely some drag force. And that is why roughly 10% of your drag forces, it can be attributed to your front wheel. That's because, like I said, the wheels don't have the, unfortunately, wheels have to have the shape of wheels. You cannot, they cannot be designed aerodynamically, unfortunately. If you look at, the other components, right? For example, if you look at your floor and diffuser, that is where you get almost 55% of your downforce. And this is actually a very efficiently designed component. Why? It does the job. It gives you the downforce. Look at the drag force. It contributes to only, say, 15% of your, what do you call, 15% of your drag. So this is exactly the type of analysis that you need to do. This is the type of analysis, guys. So what you need to do is, when you design your car, you're designing it, when you design it in a CAD software like CATIA or SolidWorks, whatever the software is, you create several parts and you assemble it, right? When you do CFD analysis, you still need to retain this bifurcation, right? Meaning your wheels should be a separate component, your diffusers, your upper body, your rear wings, all of them should be kept separate. Why? Because a CFD solver can provide this type of a data if the parts have been separated out. If you don't separate out the parts, your CFD simulation software doesn't know what the front wing is. It is just running the analysis. It doesn't know what the front wing is. So if you're asking for drag force, it's going to give you one value for drag force. And don't get me wrong, that is useful. But from a design point of view, you are looking at what you call as an efficiency. So for example, you want your part, if downforce is what all you need to understand that your part should give a lot of downforce, but should give as minimum as a drag as possible. Because when you're generating downforce, you will definitely have some amount of drag. The thing is, the drag should be minimal. Okay, so getting this exact plot is what you need to strive for. And you need to make sure that this plot meets with your racing objectives. If your racing objectives are lower drag, then the trend should be opposite, right? You need to have lower drags, and there'll obviously be lower downforces also. But if there's if it's a racing track where there's a lot of turns and curvatures, then you need to make sure that you kind of have this type of a plot where you have the desired amount of downforce. On a scale of 1 to 10, please rate your understanding of this slide.